In this example, we've been given a piecewise function and been asked to determine if the function is continuous at the x value -2. If you take a look, the question has been broken down into 4 parts. The first 3 parts reflect the formal definition for continuity. So the first thing we must determine is if f of -2 exists. Well, if you look at our diagram of our curve, or our graph, you'll notice that f of -2 indeed exists. It exists at 2. When x is equal to -2, our corresponding y value is 2. So the first condition is satisfied. The second condition for our definition of continuity states that the limit as x approaches a of f of x must exist. Well, the limit as x approaches -2 of f of x does exist. As we approach from the left and the right along our curve, we notice that we get closer and closer to the corresponding y value of 1. So the limit as x approaches -2 of f of x is equal to 1. So our second condition is satisfied. The third condition is that the limit as x approaches a of f of x, it must be equal to the f of a. Well, in this particular case, the limit as x approaches -2 of f of x is not equal to the f of -2. Previously, in part B of the question, we had worked out the limit as x approaches -2 of f of x, and we obtained an answer of 1. In the first part of our question, we had worked out the f of -2, and we found it to be 2. So, obviously, 1 is not equal to 2. So the third condition is not satisfied. As soon as one condition fails, then we can no longer say that the function is continuous at this point. So, we now know that the function is discontinuous at x equals -2. The underlying question remains is, what type of discontinuity are we dealing with? In this case, we are dealing with a removable discontinuity. The way we know that is we take a look at the left and the right hand limit as x approaches -2. If they're equal, then we are dealing with a removable discontinuity, and that is the case here. The limit as x approaches -2 from the left of f of x is +1. The limit as x approaches -2 from the right of f of x is also +1. Therefore, the left and right hand limits both equal 1, or both equal each other, and we can now state that this is a removable discontinuity.